Now we are going to start with a unit that is the pressure. As you all can see that we exert pressure in one or other way, like suppose I am pressing this you can say a board, so then also I am putting a pressure. When I am trying to pass a pin, swing a pin from a cloth, then also I am applying a pressure. Likewise, suppose you are peeling a vegetables, then also you are applying a pressure. So that means pressure is generally applied everywhere. So now today we are going to start with it, that what actually is the pressure. So see, the pressure is the force acting per unit area. Pressure is the force acting per unit area. So that is P is equal to F upon A. But in this case, this force is not a normal force. You can say this force is a special kind of force. Suppose I'll just explain you. Suppose this is a table, right? And I'm trying to put a nail into it. So what I'll do is, I'll just press the nail from this side. So that means I am applying a perpendicular force. My force is acting like this and my surface is this. So that means the force that acts normal to the surface or the force that acts perpendicular to the surface is being given a special name, that is the thrust. So we can say that in case of pressure, like when we are pushing something or we are trying to pass something from this thing, like I told you that we can peel vegetables, we can just pass this thing, a small the needle from a cloth. So that means we are applying a perpendicular force there, and perpendicular force is generally in this chapter will be called, not in this, in routine also, it will be called as thrust. So that means pressure is force per unit area, and what force? Probably the thrust. So it is the pressure is equal to thrust upon area. Now if we just look at the formula, so that means we can make out the factors on which the pressure depends. So pressure is, as you can see, that it is directly proportional to force and it is inversely proportional to area. Clubbing both, we get this formula, that is P is equal to F upon A. So when I say it is directly proportional, it means when I am going to increase this by some amount, this is also get increased by the same amount. And likewise, if I just decrease the force by some amount, then by equal amount the pressure is going to get reduced. And as I told you, it is inversely proportional to area. That means if we will increase the area, the pressure will get reduced, and if we will decrease the area, then the pressure will be high. So that means it is inversely proportional, and that is why we get the formula, that is the P is equal to F upon A. We won't be writing a thrust here, or you can even write a thrust, but thrust is probably a force. So that means you can write the force directly. So this is what is a pressure about. Now we are going to look for its unit. So as we know that pressure is F upon A, so the unit in which the pressure is measured is Pascal, which is written as PA. So if I try to put units of SI unit of force and area, then I get the SI unit of force is 1 Newton and area is 1 meter square. So that means 1 Pascal is equal to 1 Newton over 1 meter square. 1 Pascal is equal to 1 Newton over 1 meter square. Now we can actually in a position to define 1 Pascal also. So pressure is said to be 1 Pascal when 1 Newton of force act on an area of 1 meter square. When 1 Newton force act on an area of 1 meter square, then it is said to be 1 Pascal. So if you get a question like this, that which quantity is being signified by Newton per meter square, then you will be saying that it is equal to 1 Pascal, and the physical quantity it signifies is the pressure. So this is what is this. Now if we need to look for the applications, so we will see that you have seen that pin is pointed. We have seen that pin is pointed. You know that why the pin is pointed? Like being pointed, so that means the area is very less. The area is very less. Less area means more pressure. So that is why the pin is pointed, because being pointed it has a very small area, very small area, as you all know. So more area will exert more pressure, and due to which only it will be able to pass through a cloth. So that is why a pin is pointed. Maybe a cloth if I am talking about needle, and maybe any part if I am talking about pin. Right. Second, we know that cutting instruments are sharp. cutting instruments are sharp. Sharp means they have less area. Again, less area will exert more pressure, and if you have a knife which is sharp, then only it is able to exert more pressure and you can peel the vegetables more easily. Likewise, we know that heavy trucks have wide tires, and moreover they have 4 or 5 tires in a combination of 4 or 5 tires together. So this is again, the wide tires means more area. More area confirms less pressure, and due to less pressure they will be able to move smoothly on the roads. Next we have is high-rise buildings. They have wide base. Wide base means they occupy a large area. So large area means they will exert less pressure. Less pressure means they can actually stand upright. Moreover, we have seen that the school bags with wide straps are easy to be carried by the children as compared to the straps which are not wide. Because when the straps are wide, so because you are going to hang a bag on your shoulders, right? So when the straps will be wide straps means more area. More area means less pressure. That means your child will be able to carry that bag full of books more easily, and it will exert less pressure on the shoulders of the child, and he can actually carry a bag comfortably. So this is what is an application we have seen, that just taking into consideration the area. Likewise, we have many things around which have more area or less area. So depending upon its use, that whether it is made to apply more pressure or whether it is made to apply less pressure. Likewise, it is specially designed, the area is specially taken into consideration so that it can work or it can fulfill its need for what it is meant for. So this is what is the applications. Now we'll take a few numericals on it, the simple numericals. So we have a solid weighs 80 Newton. See, here it is weight, but we know that weight is again a force only, a force which a body exerts on the earth. So, a force with which the earth attracts the object towards itself. So again it is a force, and if you get confused in this kind, like if you have a, like here it is written weight and you want force in it, so just try to look at the units also. So you can see it is 80 Newton. Newton means the force, right? Because Newton is the SI unit of force. So it is being confirmed that this is the force, 80 Newton. And the solid when placed, the area of contact with the surface is 1.6 meter square. So it is 1.6 meter square. We need to find pressure. So pressure is force upon area. Putting the values 80 upon 1.6, we get 50 Newton. So this is how you are going to solve for the pressure. Likewise, I have another question for you. A rectangular wooden piece weighs 25 Newton. Again, you know that this is a force, and its dimensions are given actually. That wooden piece length is 25 centimeter and width is 10 centimeter. So because it is given in centimeter, we need to convert in the SI unit, that is the meter. So that means length becomes 0.25 meters and width becomes 0.1 meter. So area we can get after multiplying the dimensions, length into breadth, because it is a rectangular block, and we know that if we need to find the area of the rectangle, it is the length into breadth. So this is what I am doing here. So that means it is 0.25 into 0.1. 0.25 into 0.1, this is the area. Now I need to find the pressure. So pressure is force, that is 25 upon area, which is 0.25 into 0.1. If you will solve for it, you will get an answer equal to 1000 Newton. This is how you are going to do numericals based on the pressure. I think you are clear with the intro, that what is the pressure, what is the thrust, on what factors it depends. We can just confirm the factors by taking into consideration the applications where it is being used, the SI unit, that is the Pascal, and the questions based on it. So this was a basic intro for the pressure. Now we are going to start that few activities where we will know much more about the pressure.